All right, let's try analyzing this function f of x equals x to the fourth minus 2x cubed, and then sketching the graph. So let's start. First off, let's find what happens when x is 0. This is the y-intercept. So f of 0 is 0. So that means that this thing is going to go through the point 0, comma 0. Now let's find the x-intercepts by setting f of x equal to 0. So I get 0 equals x to the fourth minus 2x cubed. I can factor x cubed out of that, and it gives me x cubed times x minus 2. So the solutions to this equation is 0 and 2. So what that means is my function also goes to the point 2, 0. Now, let's find f prime, so we can figure out when the function is increasing and when it's decreasing. So the derivative of f of x, using the power rule, is 4x cubed minus 6x squared. All right. So let's find the critical values. So I set that equal to 0. And you can factor 2x squared out of that expression, and it leaves you 2x squared times 2x minus 3. So the zeros of this, well, either you get x is 0 if 2x squared is 0, or you get 2x minus 3 is 0, which is the same thing as saying that 2x is 3, which means x is 3 halves. So I'm going to make a number line over here for the derivative. Maybe try that with a straight line. That's better. Put 0 on it, put 3 halves on it, and we're going to figure out when the derivative is positive and when it's negative. And then last but not least, if I find the second derivative of f, I get 12x squared minus 12x. So if I set that equal to 0, I can factor 12x out, and I'm left with x minus 1, so my solutions are 0 and 1. So for my second number line, I get f double prime of x, 0 and 1. All right. So in each case, I can actually make a number line up here with 0 and 2 on it, because I can put the x-intercepts on this line. So, all right. Let's write some stuff. So f of x was x cubed times x minus 2. F prime of x was 2x squared times 2x minus 3. And f double prime was 12x times x minus 1. So that's what that is. Get my mouse. All right. Now, let's get a different color, and let's try test values. Okay, so what's less than 0? Well, negative 1 is less than 0. 1/2 is always between these numbers. These could be different numbers, but I'm being silly and using the same numbers for all three. All right. So if x is negative 1, then this is negative 1 cubed times negative 3. That's going to equal positive 3. So f of x is positive if x is less than 0. If I try 1/2, I'm going to get 1/2 cubed times negative 3 halves, because 1/2 minus 2 is negative 3 halves, and that's going to be a negative number. And if x is 3, I'm going to get 3 cubed times 1, which is going to be a positive number. So what that means is, if I graph this thing, it's going to touch the axis at 0, and it's going to touch the axis at 2. And it's going to cross them at both. So it's going to be positive over here, then it's going to be negative down here, and it's going to be positive up here. But I can use this information to figure out when it's increasing and decreasing. All right, so let's plug negative 1 into my function. If you plug negative 1 in, you get 2 times negative 1 squared times negative 2 minus 3. So negative 1 squared is going to be a positive number, but negative 2 minus 3 is negative 5, so this is going to be negative. So that makes sense, because then it's going to be decreasing to 0. You plug in 1/2, you get 2 times 1/2 squared times 1 minus 3, which is still a negative number. Let's put it in the other direction. So you get 2 times 1/2 squared times 1 minus 3, so it's still a negative number. So it's going to decrease until somewhere around x equals 3 halves. And then if you plug in 3, you get 2 times 3 squared times 6 minus 3, which is positive. So then somewhere it's going to increase. So I can actually figure out exactly where that is by plugging in 3 halves to f of x. So what's f of 3 halves? So that's 3 halves cubed times 3 halves minus 2, which is 3 halves cubed times negative 1/2, which is negative 27 over 16. And negative 27 over 16 is what? That's about negative 1 point. Actually, it's exactly negative 1.6875. So if this is negative 1 and this is negative 2, that tells me this is the 0.3 halves, negative 1.6875. That tells me that this thing has a turning point there. Because since f prime is negative, the original function f of x is going to be decreasing, decreasing, increasing. At 0, you're going to have a horizontal tangent line. And at this point, you're going to have a horizontal tangent line. And 3 halves is going to be a local minimum. All right. So let's finish this off, and let's do it with the second derivative. Take negative 1, I plug it in for x. I get 12 times negative 1 times negative 2 is some positive number, which means that the graph is going to be concave up. If I plug in 1/2, I'm going to get 12 times 1/2 times negative 1/2. That's going to be a negative number, which means the graph is going to be concave down until you get to 1. And then if at 1, you're going to get 12 times 3 minus 1, which is a positive number, which means the graph is going to be concave up again. And so f of 1 is 1 cubed times 1 minus 2 is negative 1. So at this point here, at 1, negative 1, the concavity changes. All right, so let's get green. All right, so we're going to be decreasing, and we're going to be concave up until we hit 0, 0. Now at 0, 0, after this, I'm still going to be decreasing, but I'm going to be concave down until I get to 1. So I'm going to decrease and be concave down, and I'm going to hit 1. And then at 1, now I'm going to suddenly switch to concave up again, but I'm not to 3/2 yet, so I'm still decreasing, which makes sense, because then I'm going to go like this, and then after this point, I'm still concave up, and I'm increasing, and I'm going to increase until I get to 2, and then I'm going to cross to the axis, and it's going to look something like that. All right, now hold on a second. I'm going to open up Desmos, and we can actually see what this is going to look like. And as you can see, I actually got the shape right, more or less. Hold on a second. There we go. As you can see, I actually got the shape right, more or less. It's not, perfect. But I got the gist of it. And so that is graph sketching.